We're going to be discussing the MuxLab broadcast over IP devices today. More specifically, we're going to be talking about a particular model that we've added some enhanced capabilities, including redundancy and NMOS capability. And I'll be talking to you a little bit about some products coming up in the over IP line. And at the very end, I'll do a quick recap of our broadcast line on a few slides, just to give you an appreciation for what we cover in broadcast. So on the over IP line as a whole, including our Pro AV and our broadcast over IP products, we have quite a few different models available. We pride ourselves on the variety of products we have. I think from a market perspective, we are probably the leader in terms of the variety of products that we offer that gives our customers, the option to choose the best product for a given application for your end customers. So that if somebody needs a particular type of model for a particular application, it will do the job. We'll have a model that will do the job. With respect to the various models that we have, you can really tailor it to suit a particular application, which will give you an advantage because models are priced according to their capabilities, so you can price it properly for a given application. Our devices, again, both Pro AV and broadcast, support a wide variety of functions and features, including video wall support and multi-view support. We have low latency products, low bandwidth products that can transmit signals over the internet, products that transmit signals over the local area network. We have compressed products and uncompressed products. Now, and our products are very easy to set up and install and manage remotely. Now, today we're going to be focusing on the broadcast side. So the products we're going to be talking about are uncompressed, and they support ST2110. ST2110 is a new standard relatively new standard. It's been around for maybe, let's say, a couple of years. That was brought about by the industry. I'm sure most of you are probably aware, but for anyone who isn't, it was put together by the industry to be able to have products interoperate with each other, so from different manufacturers. So MuxLab products will work with our competitor products as well. They'll be interoperable, and there are tests that are done through the industry forums to be able to validate that products are interoperable. That makes it a lot easier for you folks in terms of interconnecting things. You don't have to worry about which manufacturer you're using specifically, and you can focus on which manufacturer you're comfortable with and the basically additional features that a given manufacturer will provide at a certain price point. And we pride ourselves always in offering a lot of capability at a very affordable price. So our over IP line for the broadcast side consists of the three models you see here. We're going to be focusing on the model in the middle, but I'll just briefly cover the other ones as well. The first one at the top is a 3G SDI product, again supporting ST2110. This particular model is supporting a one media port to be able to connect between two different locations. The next model up is a 4K 30 version, and it's actually supporting HDMI at the input. A lot of broadcasters use HDMI still, even though the predominant connector used is an SDI BNC connector. A lot of folks still use HDMI for monitoring because those types of cameras or TVs are less expensive than the SDI variety, and if you're just monitoring and it's not a critical application, that's fine. So they've asked for this type of product, and we've released it last year. And today we're going to be talking about some added capabilities that we're adding to this product, and we've got some slides to cover those details. The primary point being that it's going to support redundancy. So as opposed to the one above, this one actually has two media ports independent that you can send off in over two separate networks to be able to get your signal there and in a redundant fashion. The last product below is a new product that'll be coming out later in the year. It's a 12G version, so it supports up to 4K 60, where the one in the middle supports 4K 30, and the one at the very top, 3G, is equivalent to 1080p. So we've got varieties for 1080p, 4K 30, and 4K 60 in terms of resolution. One other mention I'd like to do is for the first one, we are developing a redundant version of that product as well. It'll be a different model, but we will have a redundant version of the 3G variety as well. So we're going to dive into the one we're going to be focusing on today. It's the HDMI product. This is a 4K 30 product, supports 444 8-bit or 422 10-bit, and resolutions all the way up to 4K 30. It supports the ST2110 standard, so it's interoperable with our own products, of course, and with other products in the industry, competitor products. Now, these over IP devices are primarily designed to be able to allow legacy cameras, for example, mixers, TVs that don't support ST2110 to be able to connect to an ST2110 enabled network. And with ST2110 TV supported TVs and cameras, etc., so that they can interoperate with those. Otherwise, those legacy devices wouldn't work. And as you probably very well know, a lot of the cameras in the broadcast industry are really expensive. So having a legacy product that doesn't support 2110 and you're trying to build a 2110 environment for your newer installations, you want to make use of that legacy camera and be able to also use it with your newer ST2110 cameras and TVs, etc. So these products are designed for that purpose. So this particular model also supports ST2022-7, and that's basically a redundancy standard. It's a Class D, meaning that it support a delay between the two different LAN paths, media paths, of up to 150 microseconds, and you still won't lose a single frame. Even if you drop your network and the backup network is 150 microseconds behind or in front of, there's a delay or difference of 150 microseconds, you won't lose any frames, and your system will continue to operate as if nothing happened. So this is for mission critical applications, being able to do that. Management of our devices are, we provide two means. One is a REST API, and that's available today. So you can use the REST API to be able to control it through any third-party software that you want. It's a known standard for this type of application, particularly in the broadcast industry. And we're going to be introducing in a couple of months, maybe less actually, we're getting close to the end, we're going to be introducing NMOS capability as well, support, so that you can use an NMOS management tool to communicate and manage our connectivity. It's going to support ISO 4 and ISO 5. Those are the substandards within NMOS that allow for discovery. That's the ISO 4. Of the devices, and then the management of them, managing the connectivity, which is the ISO 5 portion. And that will be available, by the way, via a firmware update. That'll be available on our website for anyone who already has the product. Same thing with respect to the redundancy. This is a new feature we're just adding, the redundancy capability, and that is also available as a firmware update. And our firmware updates are free. So the product operates uncompressed on a 10 gig network and will send a 4K 30 signal on either of the two media ports. So again, we have two media ports. They're independent of each other. They're two 10 gig ports, and you can send the signal in one direction through one network, and you can send the same signal from the other media port to another network that you can use as a backup or what have you, and or actually both can be live, and it will basically use one of the ports and sense and keep track of the signal. If anything goes wrong, it'll automatically pick up the signal from the other network uninterrupted from a user perspective. Because these are uncompressed products, latency is basically zero. Obviously, nothing is zero, but from a marketing perspective, everyone in the industry calls that a zero latency product. It's because it's so small that the human eye or you wouldn't notice anything, any difference, any delay at all from a human perspective. And in addition to the two media ports, we also have a 1 gig console port or control port, if you will, for managing the device. That allows you, and a lot of customers have asked for this, specifically, in fact, pretty much all customers have asked for this, to be able to have an independent port for control that could be from a separate network. So a lot of the broadcast folks have a media network for their video, audio video, and they have a management network where they do all the management of their devices from a separate network, and they keep them isolated from each other. You don't have to. You can still use the same network if you want, but you have the option to do that. So all three ports, the two media ports and the control port, have their own MAC address and their own IP addresses, so they're completely independent. In the future, we're going to be, we've got an RS-232 port and an audio port, which can be assigned as an insert or an extract on the encoder and decoder device. And we're going to be they're currently not supported in the firmware. We're going to be supporting them in a future firmware update. But the hardware is already there to give you that capability. This particular model, the 774 model, comes with SFPs, comes installed with multi-mode fiber module inside the unit. And if you use OM4 fiber, you can extend the distance between either the encoder or the decoder from the Ethernet switch up to 400 meters using OM4 fiber. If you use OM3, it's about 300 meters, a little less. So it allows you to extend your devices from your network for installations that happen to be further away. Like you can see here in this example here, you've got a hockey rink. Things are spaced out, so it allows you a lot of breathing room to be able to connect your devices further from your Ethernet switch if you need that capability. And of course, being an over IP device, these products support point to multi-point, multi-point to multi-point, and also point-to-point applications as well if you need that. So here's just a glimpse of how you would use it. So basically, you've got a connection from a source. In this case, I'm just using a camera. You've got two devices with a camera connected to each at the input side, and on the output side, you've got a monitor. It could also be a mixer or other device, but in this case, I'm just showing a monitor as the output device. Okay, and essentially, what's happening here is, and these are basically HDMI connections, right? At this point, and essentially, on the link side, you're connecting to a network, and I've got two networks set up. I've got one here. It's a 10 gig network 1 and 10 gig media port network 2 set up, and they're basically acting as redundant networks, and each device has the two media ports. So you would send one port to one network, and it would come out and go to the other end, or to whichever receiver you want. And you do the same thing with the other transmitter and all the receivers. So each one would go, you send one connection to one network, one connection to the other. And then if one of the networks happens to fail, like as in this example here, let's say this network goes down, this network will continue to operate, and it'll detect that there's no more signal here. If it was picking up the signal on this port, it will automatically switch over to the other one, and there will be no loss of signal at all on this side. In fact, you won't even lose a single frame if the delta in timing between the two signals is within 150 microseconds, which is an eternity for electronics. You won't even lose a single frame. Okay, it will be completely unnoticeable. And the same holds true if the other network fails. So it'll just, if it was, again, reading from this one or reading from this one, it'll just either switch over or continue reading from the one that's working, again, without any signal loss whatsoever. Okay. So that's the over IP devices. I forgot to mention at the beginning, this is going to be a shorter presentation today, but I just want to do a quick recap of our broadcast line, just to give you a reminder of the broadcast products that we do offer in addition to the over IP devices that I spoke about. The ones that the over IP devices I just covered are ST2110 compliant products. We do have an over IP device that is a 3G SDI over IP device that uses compression and is not ST2110. This is an older model that we've had. It works hand in hand with our Pro AV products as well on the HDMI side, and in fact we can exchange signals from SDI to HDMI between this device and the Pro AV equivalent model that we have on the Pro AV side. It's the model. This is the model 756, and we have a model 754 on the Pro AV side. And you can actually go HDMI in on a transmitter of the 754 and come out of this 756 on the RX side on the SDI side, or vice versa. So it allows you to mix and match. But it is a compressed environment. It is an older product. The newer ones, of course, are uncompressed and support ST2110. In addition to that, we've got a network device that's a gateway between the analog audio world and the Dante networked audio world. So this is a product that allows you to connect analog audio devices, two-channel audio devices, to a Dante audio network over Ethernet. We've got a number of extenders. This family being shown here happen to be multiplexer extenders, if you will. They have 4 inputs and an output. And basically, they allow you to multiplex multiple signals and send it over a link, point to point, to the other end. We've got a copper version on the top. The top two are our original models. We've got some enhanced models that we introduced afterwards. So the top ones give you the 4 inputs and an output for the link side. The copper version can go up to about 100 meters, and the fiber version, we have both multi-mode and single mode varieties. And they will extend up to 400 meters on OM4 on the multi-mode side, and up to 10, 20, or 80 kilometers on the single mode side, depending on your needs. Each one has a different part number, so you can decide what distances you need and buy the proper model. The below 2 models are a newer introduction. They do the same thing, but they add the ability to have a return channel. So you can either use an Ethernet port to return. There's an additional Ethernet port here that you can use to send a return signal back to the other end. So you would multiplex four devices in one direction, and you could send back one signal back to the source. And this one here is the same. You've got 4 in and a return, plus the link connection. Okay. Just one other point I want to make about all of them is they can support when you multiplex 4 signals. The 4 need to be HD SDI signals. If you have 3G SDI, we can multiplex 2 of them, and if you have 6G SDI, then it's just 1 port that can be sent over the link. The bandwidth of these devices, in fact, these 3 here is 6G maximum in total. Okay, this one's a little bit different. This is the fiber version of the return channel variety. This one actually supports a bandwidth of 9G. So you can actually have three 3G signals going in one direction, or four HD SDI signals, or even one 6G and a 3G, where the total is 9G going in one given direction. Okay, plus the return channel. These two, again, support the return channel capability. These are some additional extenders. We've got a bail-in, which is a passive device. This will transmit HD SDI for you in an extended distance. So you connect to your equipment on this side, and you've got a copper link on the other side. We've also got an extender receiver combo kit that will extend 3G SDI for you. And we've got another extender that can extend 3G SDI, but it's also a converter. So that on one side, you've got 3G SDI on the transmitter side, and on the receiver side, you get an output of that's HDMI that you can connect to an HDMI TV, for example, for monitoring purposes. And this device here is a simple converter. It allows you to go in 3G SDI and come out HDMI to an HDMI TV. At the same time, it also has an SDI out. So even though you come in, you actually have a loop out where you can connect to another one of these and have another HDMI signal coming out. So if you put a bunch of these together using this loop architecture, you can actually create a splitter as well. It's a splitter converter, splitter from 3G SDI to an X number of output HDMI device with chaining them together. We've got some pure extenders. These are single mode fiber extenders for 6G and 12G. Obviously, each one of them can do 12G on down, and this one can do from 6G on down, meaning 6G, 3G, HD, and SD, and same for here. It goes 12G, 6G, etc. on down. These can go many kilometers in distance because they're single mode fiber variety. This model here, the 6G, can go up to 20 kilometers, and the other model can go up to 10 kilometers, the 12G version. And we've also got some splitters. These are 12G splitters. So again, 12G on down, so 12G, 6G, 3G, HD, SD are supported. And basically, we've got a 1x4, 1x6, and 1x8, depending on the model that you're interested in. And I've got a couple more slides left. This is a testing device, a testing tool that installers can use in the field when they're doing their installation. Often they don't have the TVs or the sources ready when they're doing the wiring. Cabling the infrastructure, basically. This allows you to simulate or to replace the actual source with this generator and replace the TV with this analyzer. These are battery powered with rechargeable lithium-ion batteries. They hold a charge for up to 5 hours, so you can be in the field without power, being able to generate signals, both HDMI and SDI. It'll do 4K 60 on the HDMI side and up to 3G SDI on the SDI side, and generate those signals into your infrastructure and receive the signals on the analyzer to make sure that nothing was corrupted along the way, along your path of your install. So that way, when you finally do get your TVs and your sources, you know that your infrastructure is working correctly. And lastly, we've got some monitors that are rack mountable, a dual version and a triple version. These are used in wiring closets so that if you've got signals going out into a large facility and you can't look at the TV output and you want to get a glimpse of it in the wiring closet, these devices have a loop, an in and an out, and a loop out for both HDMI and SDI, 3G SDI. And so you can basically spy on and get a duplicate of what's being sent out into your infrastructure, just to make sure the signal is correct. Okay, it allows you to monitor those signals. So, whoops, sorry. So that's our presentation for today.